How's it going, everyone? Welcome to another video. Gabriel Gonzalez here again. We're going to talk about these application state and network connectivity. This is part of the front-end system design as a way to know the fundamental if you're going to be a UI specialist, so you cannot build web scalable applications. The idea here is that you're not going to provide this service to other companies, but also to understand is the fundamentals of how to make this design of system way much more easy to process, to work with, and to enhance, develop. So there's also another very interesting application here, or another course, might be go beyond the scope of this course, that is the UI enterprise UI development. Well, in that we look at how can we make all of these applications scalable applications, maintainable over a long period of time with a wide range of contributor in large teams. So this is two sides of the same coin. So first we need to look at how we're going to build and design this kind of UI systems, and then how we're going to maintain them. So as you can see here, this is now part of the standard of the industries, and luckily for me and for us, this is made by Steve Givney, a software engineer with over a software engineer that now previously worked for over 3 years at JetBrains, and now he's currently at Meta. But the idea here is now he's bringing his experience as a way to now have a way to organize. How can we now describe is the story, especially when we need to create scalable UI applications. Why this is important? In my particular case, because we make sense of the world through stories. So by looking at this particular course and understanding is that this storytelling of how do we get here, especially by looking at the application state, the applications design, the design of application state design. My bad. Now we can understand is not only how do we get here, but actually what are the challenges, the challenge that we're going to face as we now still in this career, right? So not only the current challenge, but also those challenges that come up here. And that's quite fascinating, one. And second, that's also when you can provide value as a software engineer, right? As someone that can now build all of the things and can maintain that. So the whole point of this also is to, as an individual, as a service provider, you look yourself as a business, one, and then you can provide some of the solution to all of these particular companies. So by understanding now how all of this top tech engineering and working for those top tech company actually are solving their problems, and how now they're reusing some of the tools, a lot of the time we can make sense, one, and use all of that to solve this mid or small clients application. So all right, so the TLDR of this is that we don't need to actually is a framework, by the way. We just, in fact, can we do all of these kind of things, create this system design by just using simple JavaScript, right? And we can now prevent all of these merchants of complexity, which is something that I think that is what they're doing, right? But in any case, so here we are, right? So far, so good. Okay, we talk about is the introduction. Today's video, we're gonna focus our attention is on this application state and network connectivity, and we'll make a quick recap of how do we get here, right? Because at the end of the day, as we now build applications in the software for companies, usually for finance, healthcare, or in any one of them, e-commerce. So we need to build is this application that is made of the front end, the API, and the back end. So the areas of responsibility for the front end, you have now the the API communications. So what are the protocols? How I'm going to communicate with that layer, with that server. Also is how we're going to manage and store, or how we're going to store and manage our data here from this application state, all right, which is actually is comprised in this thing, in this area, in these two topics, okay? And then how can we now manage these complex user interactions here, and what are the most common use case out of that, which is, well, using the observed design pattern. How can we use it in intersection of server, the mutation as well as the resize, okay? And the other aspect is now the application, the asset management, right? So here is when we're gonna look at the HTML, CSS, and JavaScript, image, fonts, and how can we actually manage those assets in a way that is, of course, provide the best valuable as possible. And then last but not least, actually make all of this Lego pieces, so join all of these Lego pieces together as a way to now provide is a solution for that. So this core fundamental that we need to know is that how the browser now treats the HTML elements, and how that now the browser creates something known as the formatting context, which is the way of how you can set a set of rules that these boxes will behave. And boxes, I mean, is the HTML, which is the way how now the browser treats all of these HTML elements with a box around it, as a way to now understand and put those elements on the screen. So how now is, so now when you use, for example, blog and inline, also anonymous, each one of them has this formatting context, this set of rules for that. And how can we now is connect that concept with the stacking context, which is the way of how you now put elements out of the normal flow, this normal flow that starts from left to right and top to bottom, which is the way of how now the browser actually going to render all of these elements that you put it. But when you need to actually create this stacking context of putting elements outside of the normal flow, as a way to now compose is several part of your UI, okay? How now we can use is the position absolute, relative, fixed, and how that works behind the scenes, what it's doing. And the reason of understanding now the stacking context is as a way that we can make optimizations over these layers. Optimizations that is needed, or that we need to do, especially if you have to handle is a lot of small elements in your UI, right? Why this is important? Because especially for a mobile device, when you want to handle all of these elements or animations, you want to show most of the time, a good example of this is for example, when you want to now show some visualizations that contains a lot of nodes, a lot of HTML elements, SVG elements, okay, how you can now tell to the browser, hey, I would like you to now optimize this particular layer by using this now transform, which is the way of how you can now tell the browser to say, hey, this particular stacking content or this element here, okay, I want you to now use the CPU, the GPU, rather than the CPU. So because older applications or older browser heavily rely on the CPU as a way to now transform all of the HTML, CSS, and JavaScript into pixels on the screen, okay, mother browsers now uses the GPU for that, which is something great, which is powerful. So the process of how now the browser actually pass through the do this transformation, all right, is known as the critical rendering path. So this is when now the browser it takes these HTML files and CSS and then transform into something that the computer can understand, a representation, a model called the DOM, as well as the CSS object model, all right, and now it combined to a render tree that contains all the necessary information for how this website will look like, as well as how this website is structured and how it's gonna look like. So this render tree, right? Now that has all of this information, now that it's merged that, the browser merged that, and then it passed now to the layout phase. So this layout phase, or known as the reflow phase, is one of the phases of the browser that calculates the position of the elements on the screen. Okay, it calculates the geometry. Hey, what is the dimension of this element, as well as the position of the elements here. There is a very interesting video that I'm not gonna show quickly because I just want to move on to the next topic. But there is a very interesting video that you can take a look that say, hey, this is now how, for example, Gecko, this engine actually put all of these elements. It's going to now, it's going to put all, it's going to calculate the position and the geometry of all of these elements, right? And this is a very interesting thing, especially when it renders Wikipedia. Awesome. So the idea here is that because the more you trigger, so this reflow is triggered by usually by CSS, by running script that alter is the position or the geometry of these elements. So for example, width or height or the position as well. So because now it has to actually calculate that, all right? And if you want to skip those calculations, there also are some specific CSS styles that allow you to, well, cover those specific use cases. So this is now what happened after the reflow happens, okay? And the more CSS styles and the more elements you manipulate, you modify, you talk, the more elements you manipulate, right? The more elements you manipulate, or the more you manipulate the DOM or the CSS, particularly the position of the position or the geometry, all right? The browser needs to actually pass through the reflow phase. So this we can skip that. We can skip the layout calculation by saying, hey, I want you to use now this particular property that doesn't trigger those, all right? That you have background filter and so on and so forth. But the idea is to skip that calculation, right? And pass now to the paint phase, which is or the render phase, this is the phase that now the browser say, hey, now I got all of the information to actually paint that or have this now visual representation, or get all of this data and now transform them into a visual representation, to a bitmap, something that I mentioned here. No, I didn't mention that. No. Okay, but no problem. Is the paint here? That's right. So this is it. This is passed now for the paint, where you say, hey, now I know all the information that I need in memory, as a way to now is generate this bitmap, generate this particularly pixel matrix, where in each one of those slots I'm going to represent something like 256 bit color, all right? And now, for example, Mac MacBook Pro has a max resolution of 3000 times 1900, something like that. Which means is that on each one of those matrix bitmap, you have now 256 usually. Perhaps you can represent more color, but you can represent is 250 colors for each one of those slot on this matrix, on this bitmap, right? So this is the process of how now the browser is saying, okay, now that I have all of this information that I'm going to paint and I'm going to show, that I'm going to display now as a bitmap, then I want to now compose it, especially if you define several layers, right? And then this is now the final form of this. This is something very, very interesting because this is part of the reflow MDN, exactly, reflow, populating the page. Okay, this is now the process of how this actually is working behind the scenes, as a way to understand that you know what's going on behind the scenes, right? The render, that's right, where it calculates the style, and as well as the layout, right? So on the style here, the third step is the critical rendering path. In the critical rendering path is combining the DOM and the CSS object into a render tree. That's right. And then now calculate is the position of those elements as well as the geometry with the layout. Then it's going to say, hey, let me now actually paint that, using a bitmap. All right. And this is when anytime you create now a particular layer, where, for example, anytime you use is the graphic layer, you actually now creating is this particular layer. So layers do improve performance, but are expensive when it comes to memory management. So it should not be overused on your web page and optimization strategy. And then it's going to now compose all of that. So as the page continue to load, asset reflow can happen. Recall image that arrived late, and then reflow as repaint and decompose them. So only then is when your page becomes now interactive. And this is here we are just describing is now this particular process. So once the main thread is done painting the page, we will think that we'll be all set. That isn't necessarily the case. If the load include JavaScript that was correctly deferred and only executed after the unload event fires. So time to interactive is the measure of how long it took for the first request, which leaves the DNS lookup and the TCP connection when the page is interactive. Interactive being the point in time after the first contentful paint, when the page responds to user interactions within 50 milliseconds. If the main thread is occupied parsing, compiling, and executing JavaScript, is not available and therefore not be able to respond to user interaction in a timely, less fashion. So very, very, very interesting quick overview here. Okay, as a way to now, we just describing is one piece of the, we're just describing is one piece of the process of populating the page. So how browsers work, we're just describing is the critical rendering path. And this is something quite interesting. Very, very, very interesting as a way to understand what is doing behind the scenes. As a way to be able to describe what is this. Be able to describe what is this. So in the first step, exactly, be able to describe what is this. And this is quite interesting. Why a lot of people actually are describing. Why actually? Okay, it's a lot of people want to check if you truly know what you are doing, the thing that you're doing, and all that kind of thing. Basically, Yeah, completely, man. Completely, completely, completely. So navigation is the first step in the loading a web page. You record whatever we use a request a page by entering the. Okay, so this is not describing is this high level overview. Populating the page, how browsers work, recommending web page timing, how long is too long, speculative loading, understanding latency, using DNS prefetch for that, which is what now several companies actually is using that. Animation performance and frame rate, CSS and JavaScript animation performance, critical rendering path, lazy loading, navigation and resource timing, optimizing startup performance, okay, performance monitoring room versus synthetic monitoring, performance budget, performance fundamental, and populating the page here. So fast sites provide better user experience. User wants you are a user as well. Users want and expect web experience with content that is fast to load and smooth to interact. Two major issues in web performance are issues having to do latency and issues having to do with fact that the most part browsers are single threads. So to achieve that performance of this better experience is that you need to you need to understand that we have to deal with latencies because this document is not local, it's thousands and thousands of miles away. And also that the browser that this over 30 million line of code here that you put it here, a million is Firefox a line of code, okay, that actually have over 31 I think they update this oh yeah, they actually do this. They add more code to this. Oh crap. Oh crap. Very high activity. Black Duck. The AppSec leader has a new name. Synopsys Software Integrity. Minimize business risk across the entire software development lifecycle. Black Duck. Secure code as fast as you write. Automate testing without compromising velocity. El City. Interesting. All right. Very, very interesting. Okay. That's interesting. That's good. Okay. Black Duck. Interesting. Calgary, Canada. There's a lot of in Canada. Senior Regional Sales Manager. Director of Sales, Virginia, Burlington, Germany. Controller. And the controller. Controller is in finance. Controller. With adhere to GAAP principles. General accounting acceptable principles. General accepted account principles. Manage local statutory accounting and reporting for Japan and Asian Pacific Group. 10 years of experience in accounting, 3 to 5 years experience as a controller, strong knowledge of US GAAP, familiar with reporting requirement for Japan and Asian countries, flexibility, proficient in NetSuite. From Oracle, excellent leadership and communication skills, detail oriented with high degree of accuracy. Interesting. Controllers. In finance, payroll specialist, remote UK, payroll staff, remote in Japan, cybersecurity engineering, and IT staff, IT senior staff. Research and development, software engineer, principal in engineering. Exactly, more like leaderships. This is a lot of leadership roles. Exactly, a lot of leadership roles. Anyway, okay. The using is not this interesting. This is some sort of GitHub, something like that. Anyway, but the browser here contains more than 31 and a half million of line of code, which is not trivial stuff, and that's what in most of our browsers are single thread, line after the another. So this particular application is line after the another, which is something good, especially if you are now a human, like I am, and then you want to write this kind of applications. You need to actually be that one line after the another. So latency is the biggest threat to our ability to ensure fast loading page. So it is its goal to make the site load as fast as possible, or at least appear to load super fast. So users get the request information as quickly as possible, and network latency is the time it takes to transit bytes over the air to computer, over the cable, right? Over the medium. It can be cable, it can be air, but it's that's network latency. Web performance is what we have to do to make the page load as quickly as possible, right? So this is the two major issues that we have in performance. Again, this is not about performance, this is more about state management, okay? And I think this is quite interesting as a way to recap that particularly the way of how that you populate that, as a way to understand now what is doing behind the scenes. How can we now improve each one of, how can we improve reflows as a way to prevent, to trigger that, and now how these particular layers are created. In the face of composite layer, you have now the render tree, you also have the you have now exactly the render objects, and then you have now the render layer, which is usually when you create now is in the stacking context. All right, let me check if that actually I'm right. Stacking, wait, what? So it's a render layer, okay. The render layer, render blocking. Why render blocking? Is to any part of the process of loading a website that block the rendering of the user interface. Render block is bad for performance because they increase the length of the time users can interact with. For example, viewing code or interacting with controls. The most common causes of render block are initially loaded CSS or JavaScript files. So again, we are looking at the render layers, right? The render layers, or the compose phase, right? Compose phase, critical rendering path. Let's go backwards here. On the compose like once the browser receives the first chunks of data, but we're looking here at the compose, which is the render layer, right? And the paint and the compose. Well, in any case, it's not that quite illustrative. Perhaps now in Google here is more illustrative by saying it's the composite. Okay. On the browser face, composite face, on the browser, right? Rendering performance, which is this one, right? There are 5 major areas that you need to know about and to be mindful if you work as a web developer, right? These 5 areas is like this, as we mentioned here, as it is. So stack calculations, layout, paint, and decompose. And this is quite interesting as a way to now prevent this kind of things. So the point of this, okay, is to now being able to create this narrative around that. And when we need to actually tell the browser to improve this particular stacking context, okay, we can do that by communicating to that this particular CSS that is going to now use the GPU. Why this is important? Because if you're going to create now user interfaces, which is interacting with the DOM, which is part of this, we need to know is how to do that as a way to create is or low-level components or drag with tools, or you want to create your own blueprint. You want to create your own portfolio without any of these framework blueprints. All right. So that's why we look first at the global objects as a way to understand now this is the window. As a way to know where are the objects that we can have access to this, right? So you have now the document. We have now the window, the document, the body, as well as the head, and then the DOM hierarchy. It all starts with the node, and then you can have now text node that extend from the node. Also the elements that inside of the elements has now this HTML elements and SVG elements or any XML element that extends from this element class from the node abstract based class that also can have is the where now it extend from, so HTML document extend from this particularly node, and then you can have access the window from this HTML document. The whole point of this is to understand this class hierarchy, as well as what are the methods that we can use as a way to query any of these elements in the DOM tree. Okay, get element by ID, get element by class name or tag names, and query selector and query selector all. What is the TLDR of this? And that is what is the performance overview as well as the best practice. Okay, so because working with get element by ID is great if you want to make this as a starting point to get all of these elements, all right? Or if you want to now use the get element by class name or tag name, which is something that we are not using because it now give you is a live collections from these elements, and that has been an approach that is not that has been an approach that is very hard to work with, right? Even though if you need, for example, is lower, if you need a lower memory overhead, you can use them. And the other is the query selectors and query selector all, where each one of them returns a copy of that element, and then we can work on that. So this is now the performance overview as well as what are the best use case for this. Or the best practice with using the get element by ID, starting from the root elements as a way to get all of the necessary elements that you need to work with. Use the query selectors, or simplifies the query selector. Uh, and then also look at how can we now add and remove elements, and what is the trade-off, and what is the elements that we can use, and also how can we create our first is simple UI element, which is a card. Okay, how by using now the template we can tell the browser, hey, I don't want you to now show this element quickly, I just want you to now hold that in memory, and by the time you render that element, I want you to now access through JavaScript at runtime and be able to now is create the data needed for that. So query that element and then actually iterate through that to find is the title and the body, and then I can now is create this particular element, this particular card here, as a way to now is put this on the as a way to put this on the as a way to put this okay, as a way to put now this card at runtime. So once I populate that with proper data, then I can append that to the proper element. So this is so far so good, very cheap, very easy to do. There's nothing fancy about that. Actually, very interesting. And when you now look at when we need to cover more complex user interactions, for example, with virtualizations, lazy loading, dynamic UI elements, or marketing. Okay, we want to now get some analytics from this about how the user is now, for how long the user is actually looking at this particular page and that kind of thing. We need, back in the old days, we didn't have a particular way of doing that. So those alternatives were actually quite messy and not performance. That's why we have now to cover this particular use case that I'm going to mention. We have now the Observer API. So for all the example that I mentioned before, or the use case, virtualization, dynamic UI, dynamic loading UI, for analytics, lazy loading, we use now the intersection observer for that. We also look at how can we use that, what is the setups that we need to do, and how this intersection of observers works, right? We also look at the another use case, for example, like rich text editors or graphic tools, graphics, or graphic tools, right? When it comes to actually keep track of how these elements change. For example, the attributes or the data or any of the children components. So that's what we have now is the mutation observer. And the other is the when it comes to handling is responsive designs or charting tools as a way to make it look like this quite useful. For example, for trading, this is actually something tremendous that is important to that. That's what we use now to resize observer. And each one of them we look at how can we set up that, how it works behind the scenes, and what are the most common use case for that, as well as a particular example of how can we now render elements as we scroll. How can we now, when we change the content of a particular sections, how can we now change that to something that we need to, all right? Using the mutation observer and the resize observer is that, hey, how can we now is make these particular elements and when we resize it, when the content or when inside of the box model, when the content and the when the content of the border change, giving a particular, to pass to a certain threshold, we want is to apply something here. So that's very interesting. We also look at the virtualization technique, which is something that I didn't dedicate too much time to look at that, because this is something that is very narrow specific to mobile applications, which is great. So when we need to actually look at that, we already know what it's doing and how to implement this thing. But for our use case, and also we look at how can we implement, for example, is the intersection observer, usually with the intersection observer, and as a way to now recycling some of these elements as it is. And what we really care about in today's video, which is the application states and network connectivity. So now that we know how to create these user interactions, the core fundamentals on each one of the, to cover some of the most common use case here, all right? When it comes now to actually manage the data, okay, we look at the best practice or the recommendation of the application state design as a way to make that happen. And that is identify what is the data that we're going to store here by saying, hey, what is the class of data that we're gonna store here, as well as its property. So with the class of data, usually we store is now configurations, user themes, local accessibility, font size. Also, we store the data from the UI state locals, right? So for example, with the selections or the forms, and that kind of things. So data that is relevant to the UI, and then now the server data or the business data, the application data, right? The business data, data that we get from the server, from the server. So for each one of these type of data that we want to store, we say, hey, what is the properties that we care about? You may wonder why. Because at the end of the day, we want is to make the management and storing quickly as possible. So easy to work, easy to scale, and that kind of thing. So that's why we look at what is the properties that we from this data that we're going to store and manage, which is the frequency of accessing, the read and write frequency is one of them, the access level, as well as the size of this data. So great, because once I look at, so once we know this, which is, this is the property of this particular data that we want to store, remember what is the end goal of this application state design, which is the principles, okay? The principle of this application state design is to, well, make the data or minimize is the, so make the data easy to access, so fast to access. Make this data easy to manage. That's one. But first is make this data quick. So minimize the cost of read and write. If your application implement and insert functionality, well, now is minimize the search cost. We're gonna see how we can do that. And minimize is the memory use, the RAM memory usage, right? So to cover the first one, I will look at a particular example here as a way to create now this application, as a way to, the minimize is the access, the minimize is the read and write. So by now using some data some normalization here, and normalization is a way of how in database, which is a concept that I have from the 60, when you want to now organize your structure, organize your data in a way to remove duplicates and improve, in a way to remove redundancy. In yeah, in a way to remove redundancy, and what is the other one? Yeah, to remove redundancy, and Jesus, to remove redundancy, uh, and improve consistency as well as readability, read access, read and write access. Okay, um, we follow is particularly normalization, which is a way of how you can now improve is uh, how you can save space in memory and avoid any. Uh, so how you can save space in memory and um, yeah, how you can save space in memory and how you have consistent data. So for consistency and avoid redundancy. And while doing that, you improve, of course, is the access time, or you minimizes the cost of read and write the data, right? Uh, so that's why we look at this normalization. This normalization, where the goal of normalization is to optimize the access performance, have a organized structure. Okay, so optimize the access performance as well as the storage performance. How are we going to organize this in the most effective, efficient way? How are we going to store that? Optimize store performance, optimize access performance is like, hey, how quickly can you get this data? So for example, it's like if you go to your fridge, okay, and if you organize everything neatly, you say, hey, this is the vegetable, this is now the cheese and milk is dairy product, and then on top of that you have now is the protein, all right. So now that you have all of these things organized, well, you can actually get that access to the data quickly. So this is what normalization is doing. The name itself is pretty self-descriptive, normalization, as you can see. But it's that is to optimize is the access, is to optimize is the access performance, optimize is the storage performance, and then provide readability and maintenance. So provide to the developer is that, hey, because this is the way of how we doing the things. Now other developers that knows that can actually make changes to that. So improve the readability and maintenance. So this normalization there is right now 7 type of normalizations. Most of the time we work until in the front end we work until the second normalization form. Up to 3, depend of your use case. But the first normal form saying is like all of the fields in that particular object must be atomic and must have an ID, right? The second norm, the second formal, Jesus, the second formal norm says, okay, now, now that you have all of these atomic properties, okay, non-primary keys, okay, depend on the entity primary key. In other words, is that property of that entity, properties that are not from that entity, okay, must be created. So properties that are not from that entity must have a particular table, right? Which is something that they do here. So non-primary key depends on entity keys. It's like in this particular object that you have all of your atomic elements, right? And by atomic is that you don't have anything nested there. You have all of these atomic things, and then you have the ID, all right? Now, it's those that are not primary key, okay? Non-primary key depend on entity primary key. Which means that you're going to now put all of those properties that are not from the entity into a separate entity that contains now an ID and all of this property from that entity, right? So that's where we look here at this one. So let me see. Fucking hell with you. It leaves me blind. Is that you got it something like this, right? So the second formal noun say is like, hey, now that we put all of this ID here, okay. The second normal form say is that non-primary keys depend on entity primary key, which is interesting. Non-primary keys, the property of this, depend on the entity primary key. So you must have now an index or this primary key associated to all of this data. This is the second formal norm here. Exactly. Again, remember that at the end of the day, the entire reason of looking at this is because we want to optimize this storage. We want to know is optimize this access, and how do we store the information, and then how we now and then how we how by following is about how by understanding this we now being able to improve the developer experience and the maintainability, not for ourselves but also for others. So this is the second formal noun. Interesting, the second formal noun. It says all of those non-primary key must depend on the primary key. Interesting. Exactly. Non-primary key depends on entity primary keys, right? So for example, and the third normal form say is that the second formal noun plus it say no. Non-primary key only depend on the entity primary key. So for each one of them, each one of those rows, you're going to have now is this unique ID for that. So this is quite interesting because here in this object we say, hey, this is the ID, all right? And then you have now a jobs with the title and the department with that ID, right? And then we have other normal forms that we're going to apply, but at least just to reach to the second, third formal noun, normal form. That's interesting. That's very interesting. Completely, man. Completely. Okay. Okay. So here you're starting to see how we can transform this particular data into now a data that is easy to access because it is organized. We improve the organization, we improve the storage performance as well as the access, all right? And also by following this practice of normalization, if other developers actually follow that, we can improve the performance, we can improve the maintainability of these applications. That's one of the reasons why practice, why discipline is so important, man. Especially if you're going for any activity, man. For any activity, and all of this discipline must have a goal, because if you're disciplined for the sake of disciplinary, why do you do that? And this is the reason why actually I'm talking to this as a way to understand how do we get here, make sense of all of these things that we have learned so far, and that makes a lot of sense. And that makes a lot of sense. However, because we split that, right? Because now we apply is the second formal norm, which says that, hey, non-primary key must be or must has be non-primary key should depend on, so non-primary key should depend non-primary key depends on the entity primary key, okay, which is the way of how you can say this ID will have all of this non-primary key, all of these attributes of this data. So as you can see here, we get is this message, which can be a collection of messages here, right? So we can have the message ID with all of this message here, similar to the conversation. You can have multiple conversation in your chat applications with multiple persons, right? Similar for the user ID. And as you can see here, because this is now the message, okay, and the message will have now several of this, right? And so far we have now improved the access time. But if this application requires you some insert feature, now we need to also provide that. So how can we do that? Well, instead of actually here storing all of this, instead of actually here storing all of these elements in an array, in a simple array, where each one of these messages will have now this array of message and so on and so forth. That's right. And if you want to actually look at that particular, you need to get access to this. So one thing to improve or to minimize the search cost is by implementing something known as the index table or inverted index table. What does it mean is that this particularly, again, this is for improving the search. This is very narrow specific. Very narrow specific. If you want to improve now the search operation here, okay, you can use something called as the inverted table, inverted index table, which is in each one of those key we're gonna store now is the content, okay, and this content will have now is a reference to the message and some additional data as well, right? So this inverted index, all right, is now improving is the way how we going to access to this particular content, right? Or the way how we going to search for this particular content here. However, if you want to now improve that, right? So you can actually store that here and say, hey, I want to store this inverted tables here in a particular storage. It can be my local, it can be main memory, exactly, or it can be any other memory. So depend on the size of data that you're going to store here, all right? So, oh my God. So depend on the size of data that you're going to store here. You cannot put all of this data close to you. So again, you have a limited amount of data that you can store, right? So you have now this limited amount of data, and pretty much like in your cell phone, all right, or in your backpack, you have now a limited space that you can carry out things, okay, as a way to quickly access that you in your pockets, in your blue jeans or in your pants. So you have this, okay, you have now is a certain limited amount of things that you can store there, so you can quickly access to that, your keys, your cell phone, your condoms, wait, what? But the idea here is that by having this close storage, all right, we need to actually put relevant data in there. And as a way to put this relevant data, especially if you want to improve now how you're going to provide is the built-in searching operations, okay, you can now use something known as the composite key. So this is quite interesting here, right? Because not only that you have your normalized state, okay, that is pointing to that inverted index table as a way to say, hey, Now that I have all of this data organized in this particular way, that is going to improve is the access time. That is going to improve is the access time and in the storage as well. And when we need to look up for we need to search for data, okay, in each one of those messages or inside of this normalized state, we're going to create now this inverted index table that will have not only data from that will not only point to simple keys, all right, but also to composite keys, all right, as a way to now say, hey, anytime the user wants to search for, let's say on the users, anytime the user wants to search for any contact, any friends, you not only have your data improve for quickly access, but also for the way how you store that as a way to eliminate redundancy and as a way to eliminate redundancy and improve storage space, which is great. But when it comes to now search to this data, we're going to create now a different table where this table here, or a hash here, okay, where this table now their keys will be that's interesting, where their keys will be now is specific prefix of your user, right? Specific prefix of your user. This is something quite interesting, very, very interesting, very, oh my god, very, very, very interesting, but very, 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 very interesting. Jesus fucking Christ. Because not only with that you can improve is as a way to access or as a way to search is through users, but also as a way to search through orders if you have an e-commerce, or as a way to search through products or catalogs. Interesting, very, very interesting. So the question is that how do you implement that thing, right? Because you have now this application state as it is, all right, and if you want this to show now is relevant data for that, because as you can imagine is that you can have too many data loaded in memory for your users and for your message in the case of the applications, for your users and for your message and the kind of thing. You say we need to actually offloading this data to some place. Okay. Memory offloading. This memory offloading is known as sharding. Identify unused data is something that you can now pass to a particular storage, which is which storage you want to use based on the scalability on your problem. So we have now here on the web browser provides this particular storage, this particular place where we can store things, like a fridge or backpack or your pants pockets. Okay, each one of them provides some features. It's a trade-off. So yeah, we have now the local storage, the season storage. The local storage is persistent. The season storage is the local storage is persist even when you close the browser. The season storage is persist only for that browser tab, and then you have now the IndexedDB, which is also persistent even when you turn down or you turn off your computer, right? And each one of them has particular way of doing that. So the summary of this, Jesus, French those guys. The summary of this, when you are going to now manage your data management, is to say, hey, what are the data that we're going to store here? Okay, so what are the data that you were going to store, and yeah, and know the scale of your data, you know. So know the scale of your data it means that how much data we're going to store here. Okay, how much data we're going to store. That's very interesting. Jesus, we never thought about that. We just only we are just technicians. Okay, I get it. How many data are we going to store here? So know your scale, because on that, okay, you can say, all right. So this is usually the amount of data that we're going to store here on the client. All right, 100, 10,000, 100. Okay, this is the data that we're going to store. 10,000 roads or 100 roads. What is the scale of this data? And optimize accordingly. So once we know the scale, interesting here. This is a very silly question, but and also very important one. Yeah, completely. Okay, application state design. Okay, so what is the data that we're going to store here, right? So know your scale. Interesting. Very, very interesting. Yeah, very, very interesting. So know your scale. What is the size of the data that we're going to store here? Okay. So first, what are we building here? It's a chat application. It's an e-commerce. What is the size of the data that we're going to store? It's like ask yourself is a real life example is of this application state design is if I go out. Okay, if I'm planning to go to the gym, or and I say this because if I'm planning to go out to the gym, okay, or if I'm planning to go out now to do some trekking and that kind of thing, the amount of data or the amount of the size of these things are different. The scale of these things are different, which means that I'm gonna need fewer things, or it's much more practical. For example, organize the plane to the gym rather than trekking, or not even mention to go out and migrate to another country, right? So all of these have different scales. So know your scale and optimize accordingly. And this is also you can apply to your life as well. Application state design is like know the scale of what you are going to build, what you're going to run. Okay, and then always start by how you structure your data. This is pretty much like planning is go to the gym. This is pretty much like planning go to the gym or go out planning hit the gym or planning to migrate to Rio, that kind of thing. So know the scale, all right, of your data. So know the scale of your plan and optimize accordingly. But remember to and remember to start with the structure. Remember to start from how you're going to structure all of this. How you're going to structure your data. That's the second one. How you're going to structure your data. And also is that, once you know how to structure your data, then normalize to optimize access costs. If you need search, if you need to implement in search, the use is now index, right? Indexes. Because by creating all of these indexes, you may end up with non-relevant data at that particular moment. You need to offload the data to some place. So offloading that uh, when it is needed, and pick a suitable storage, man. So this is something interesting. This is very, very interesting. And that'll be all for this video. Take care. Bye bye. Jesus, completely, man. Okay, that index part here is quite interesting. It's quite challenging as well. Yeah, it is. So overview, application state recommendation. Okay. Yeah, it's silly, but if you understand that,